33B20. This one about 12 being a factor or something?
Yes.
All right.
What?
So guys, this is page 123, number 20.
What's with the question marks here? Mike?
What's up, sorry?
There are question marks right here, and why? The
There
answers.
are, yes.
They're answers right there. I split them so I have more room.
But I think when I put a question mark ahead, normally means you didn't really answer the question. So look at the question again, make sure. All right, guys, so 20 says if 12 is a factor of, what did it say? 10 squared minus 2 squared? Oh, this is, 10 squared minus 2 squared. 27 is a factor of 20 squared minus 7 squared.
So wait, what are we doing now?
This is number 23. Where am I at? 3-3 or 3-2?
3-3.
Thank God. This is where I'm at. 3-3B number 20.
Number 20.
And 84 is a factor of 80. 80 squared minus 4 squared. Okay. That's kind of freakadelic. So did anybody check those out? Did anybody do these problems besides the person asking me right now? Hopefully, this is chapter 3, so that's a few chapters back.
I did.
Yeah.
But somehow I got it wrong too.
Okay.
Like the question mark.
Sure. So you have to check to see if they're correct. And then it says, using a variable, prove why this works in general. Right? Sometimes I can't really follow, I think, sometimes what you're writing down, so you gotta make it kind of neater. So what do you guys, did these check out? If you want to pick one and try it out, did they check out? Like, what's 20 squared? 400. And what's 7 squared? 49. So what's 400 minus 49? 351. And does 27 go into 351? You can do it in your calculator.
13?
I don't know.
Yeah.
Yeah.
That's correct.
So it should go in. Yeah.
Yeah.
Should be a factor. All right. So the question really is, are these special numbers, right? So sometimes math people get all geeked out about, ooh, this number does this weird thing. So is this a situation where these 3 numbers are special numbers, or is this true in general, right? What's the form of this, by the way? What's the idea? Like, somebody else give me a 2-digit number. 2-digit number. Any 2-digit number. Give me
22.
What'd she say?
I said 22, what you said?
She said 21. I love it.
Wait.
So let's do 23. Is 23 a factor of, and what would I have to check it against to follow the same format? 20 squared minus 3 squared. Let's check it out. What's 20 squared? 400. 3 squared is 9, it's crazy. This will be 391, yes? Somebody try to do 391 divided by 23. 17? Holy shit! Right? But you guys kind of with, is anybody kind of with me? So the book gave me 3 facts, and they said, hey, make sure these are facts, right? The 3 things they told me, they said, make sure these are true. We told you this to verify that we're not, temporarily insane. So do this and make sure that 12 goes into it. Yes?
Yes. No.
Are you guys, what's happening over here? You guys okay?
Okay.
So 100 minus 4 is 96. 12 times 8 is 96. So 12 is a factor of 96, right? Okay.
And then 80 squared is what?
6,400 minus 16. 6384. That's a neat number.
And then divided by 84.
Yep, see if it goes in.
Let me see. 6384 divided by 84. That's 76.
So it goes in, right?
But then it's asking in 20.
I know.
Like check. Okay, we checked all these statements are correct, but you're using the variable. Prove why this works in general.
Yep.
Because I got, personally, I did all these steps right here. I just said this, because
No,
through
I know.
rearrangement,
Yeah.
the-
Okay. I
just
think you
did-
had the right idea. It's just it was really hard to follow. Yeah, it's a little hard to follow. I think you've got the idea. You need to like rewrite it a little more concisely because I can't really follow where things are coming from.
Because we know that there's like this difference of squares when we look at it.
Well, how do you know that? So you don't know that from the beginning, do you? Guys, so this one is not immediately obvious at all. How to do the other part of it. It's the proof part is always going to be the hardest part. I can pick numbers and check all day long. But to prove it, I'd have to check. I'd have to pick every number possible, and that would take me a little while. Yeah, so this one's really, really freaky, right? So if I have just some number, A, B, and I want to check, all right, so I really want this to make sense. So like 12, so A would be 1, B would be 2. 27, A would be 2 and B would be 7. So this is not A times B, this is first digit A, second digit B. We did something like this last time. You guys remember?
Yes.
And so what you did was correct, but it's sort of all over the place. You need to learn to rewrite your work in a more concise manner. So, guys, help me out. Everybody, help me out. So if I have a digit, if I have a number, first digit's A, second digit's B, what would I have to check about this, Emma? What would I have to check?
Check about what, sorry.
To see if that follows this.
AB follows the factors.
Yeah, if it works the same way that 12 does and 27 does and 84 does. Right, so how did we check 27? We checked to see if 20 squared minus 7 squared, 84. 80 squared minus 4 squared.
It would be A squared minus B squared.
Almost. Almost. Here A is 8, correct?
Yes.
A is 8. And what did we square?
80.
80.
So it would be A times 10.
Yes, because this is like ATB. All right. I don't know if you guys are with me or not.
Yeah.
1 TB is 2 TB, right? So this is ATB. So this would be 10A squared minus B squared. And that's, of course, where the difference of squares comes in. All right, anyway, so that's the way that starts, yes?
That's the way it starts, that's true, but then what would you have to, but then you're gonna have to do dividing. So you will have to go with I'm sorry, you have to divide it over A, and then in parentheses 10, plus B over, plus B in parentheses 1. So that would equal to.
So all you do is, factor this. Yeah, sure. Difference of squares kind of thing. And then you gotta figure out, how do you check that this is a factor of this?
Uh-huh.
So that, okay. So that's kind of, this is a huge step to realize right here. And that really is just, we wrote the most general 2-digit number. First digit A, second digit B. Could be anything. Then we wrote what it would look like to follow the format of the problem. Now at least we all know what to investigate.
So for example, if you were to put 10 and let's say our A is 20.
Well, sure, yes. if you were to make A 2 and B 7, then we get this, right?
Yes.
Okay, sure, but that's too specific. Too specific. I want to prove it for whatever A and B could be.
About 3.
No, that's too specific.
How do we know that's specific?
Anything is too specific. So any number you put in is too specific. It's not going to prove the idea. I could come up with individual examples all day long, but I can't prove it until I do for anything.
X and Y?
Well, that's what A and B are. Yeah. So you could use X and Y if you want to instead of A and B, all day long. They're just variables.
How
Anything
about-
special about X and Y except that some old white dudes in the past chose X and Y? No. Not a damn thing. It could have been A and B. Could have been R and W. Could have been A and W. Some good root beer.
Yep.
There you go.
What?
No? I don't know. We each eat. Barks is good too. Yes?
I have a question on 3.3
Oh,
set
so
B.
wait, what did you say, Louise?
Well, I was seeing if she had a question about this, and now I'm gonna say, is that enough to get you started for anybody who didn't finish it? You got a lot of this down there. You just need to rewrite what you've got.
Oh, okay.
Okay. Maybe.
Yeah.
If this is a problem you were not able to do, did you get this far? Okay, so I guess, all right, okay. If you didn't, then you're that far at least now. You can finish it now. Okay. What else? Yes.
Wait, 3.3 set B 23.
Man, my eyeballs are really freaking me out. Brooke claims that because less than and addition are for whole numbers is a property, so too should less than and subtraction for whole numbers be a property. How should you respond? All right, so what does that mean, less than and addition is a property? What the heck does that mean?
I don't remember.
You got the book, right?
Mhm.
So, this means if I have 8 is less than 11, what about 8 plus C and 11 plus C?
Oh,
Are they-
that.
Is that still less than?
Yes.
Right? Okay. So what's wrong if we try, and just to remind you where this is,
Less.
this is like on the first page of section 3.3. All right, here we go. 117, page 117. So there's one little thing. So should subtraction work? I mean, think about it.
No.
Think about it. Is 8 less than 11, right? What if I subtract 5? Is 3 still less than 6?
Yes.
Yes. If one number is less than another one, and I take the same amount away from both, they're still the same, it's still less than, yes? What's the problem though? There's one key word. Because everything we're doing is about whole numbers.
Mm-hmm.
So what's possible if I subtract some, so if I try to say A less than 11, that means 8 minus C is less than 11 minus C. What if C is 20?
Well, then. it'd be
Are we still
backwards.
working with, no,
It'd be
don't
integers.
overthink it, I'm not multiplying anything.
Integers.
Yeah, it wouldn't be whole numbers anymore. Yeah. That's the only one little thing to be careful about when we work with whole numbers. So I mean, I would tell the student that they're absolutely correct, but we're only working with whole
Yeah.
numbers at the moment. That could bring us into negative numbers. Yeah. Is that right? What's the only time that we flip the sign?
Negative. Negative.
Inequality.
Be a lot more specific.
Not
Inequality signs when you're dividing.
Dividing or multiplying by negative, yes. When they're divided or multiplied by negative, that changes the side of 0 they're on. Right? Okay. I like it. Anything else from homework?
I'm confused by, I'm still confused on 23 on, I'm still confused with 23 on 3.3B.
Okay.
I said, yes, it would be because the number smaller is more less than.
But did you, so, again, all right. This seems like a little tiny point here, but it is completely true that that works. The subtraction works for inequalities. if you are dealing with only whole numbers, right? If you're dealing with only whole numbers, will 8 minus c always be a whole number? No. So that's a problem then, right?
So it'll be not, so it'll be no, wouldn't it?
For that one little thing, it might take us to something that's not whole numbers. Okay, I like it.
So it'll be no, not always, because we might not know.
Yeah, because we might not still be dealing with whole numbers. So what you want to do is when you're teaching children math is you start with natural numbers, because that's what comes naturally. That's why we call them that. 1, 2, 3, 4. I can see my fingers. I can see 1, 2, 3. It's really hard to see nothing. So then you introduce 0. Then you introduce negatives, because that's some freaky shit. I mean, negative numbers freak the hell out of the world when they were first thought of. People were looking at that like, you're insane. How can you have negative apples? Get out of here. That's crazy. And now we're like, oh yeah, look at my bank account statement. Yes?
Can you do 14A and 14B? You said that I didn't really finish the problem?
Okay, now, so you're getting into a situation where you got to talk to me after class. That's a little too specific to your work.
Well, can you help me understand what I did wrong?
Okay, so again, see me after class. Yes? Let's see. So Ayumi writes, a to the m times b to the n equals. A, is it this? I think a lot of trouble to glare today. I love it. What's the exponent say on the AB? M plus n? Put a big old question mark there. Is that true? Help me out, guys. What is x squared times x to the 5th?
So,
Why?
because that's how they base.
If somebody's like, how many chairs in the room? Well, there's 5 chairs over there, and there's 4 chairs over there, and there's 3. And you're like, dude, how many chairs in the room? Freaking put those together, right? So if I said, how many x's are in this? There's 2 over there, and there's 5 over there. No, how many freaking x's are in this thing? 7.
7 total.
So it's collecting how many of these I've got. So what must be true about the bases to do that? They have to be the same, right? If I say how many chairs and tables are in there, and they said there's 11 chair tables. What the hell's a chair table? You can't put that shit together.
This is a chair table.
Right? That's a chair table, you're right. I have been debunked. Live. All right. So it's be x to the 7th, right? So what's wrong with what this person was trying to do? What's the main immediate thing to address? What is different here than here?
They're not the same.
Yeah, the bases are not the same. How many A's are here? M. How many B's are there? So do I have more than M A's? Do I have more than M A's here? No, I've got M, exactly M. Over here, somehow I got M plus N A's. How the shit did I do that? You guys?
Yeah.
Right? Okay, so the main obvious thing is not like bases. You can't do that. But you have to understand why. You can't just say that. You have to understand why, because it's collecting like things. Instead of saying so many x's, I can put them together. As long as they're the same thing, I can collect them. Can't collect this. I like it. Yes?
Can we do 8D and 8F and 3.3?
B?
Yeah, B.
8E?
8E and 8D and 8F, because when I did 8F, I got 8F was a bit difficult because I got an exponential point and decimal, so I wasn't sure.
We talked about 8F. We talked about 8F before, and it actually relates to the other ones. Yes, we did. Don't say we didn't.
Like,
We totally
when?
did.
When?
So 8F,
We didn't do it today.
help me out. Well, no, we didn't do it today. What does it say? There's things that existed before today. 8F is 3 to the 7th times 9, what is that? 5? 9/5?
It says 3 7 times 9/5 times 27 squared.
Squared, okay, cool. Does somebody, well, we at least did one very much like this, if not exactly this. Why are those numbers not completely distinct? Why are they kind of related to each other?
You could convert them all to the same base.
Yeah, they all are based on 3, right? So this is 3 to the 7th. I think what I did was I took this and looked at it by itself just to help you guys out. How can I, so look here. I'm gonna put the 5 there because it's there. I'm gonna rewrite 9. What is 9 in terms of 3 to a power?
Three.
All right. So what do I have here so far? And yes, I have one more thing, but you're gonna do it. I'm not gonna do all your homework. 3 to the 7 times, what would this be? 3 to the 10. Okay. One more to do that to, and then you can collect all your 3's together, right? You make the bases the same for the exact same thing we were just talking about, right? They have to be the same to be able to collect them.
It'd be 3 to the 3.
So far, yeah, sure, but don't tell everybody. Keep going. Okay.
So that one.
Anything else from homework? Yes.
Do one.
Oh, wait. Yes.
17, which in the same 3.3.
All right, so this is one about the paper? Okay. So pad of paper. 200 sheets of paper. A lot of sheets. Is approximately 15 millimeters thick. Suppose that one piece of this paper was folded in. Oh, I love this. This is crazy. Do you guys know about the whole thing about trying to fold something more than 7 times? It's related to a scene from Rick and Morty, if you watch Rick and Morty. The guy folding himself up into.
Oh, yeah.
One piece of this paper were folded in half. So now we're talking about one piece of paper. How thick is one piece of paper? How would you figure that out?
5?
What, did you say
I said
5 or did you say
divide.
divide? Okay. Totally divide, right? 200 sheets is 15 millimeters thick. You can divide and figure out one sheet is how many. What would you
I
divide
got
exactly?
this. Huh? Sorry.
What would you divide exactly?
100 by 15.
No.
No, because I got like 13 points for repeating and that wasn't right.
I really want this to make sense. If you divide 200 sheets by 15 millimeters, what do you get?
13 points for repeating.
Okay,
And that
13.
didn't make sense.
Let's listen. What would the units be?
Still millimeters.
Sheets per millimeter. I don't want to know them. I want to know how many millimeters is one sheet, right? So you have to divide the other way. Does that make sense?
15 divided by 200.
Yeah, dude. And we're cool with that. We know decimals exist.
Sometimes I forget that.
And then it says, if, suppose on one piece of paper, fold in half, then in half again, then fold again, and so on, until the piece of paper has been folded in half 30 times, how thick would that folded paper be? You want to kind of make a pattern. Oh shit, so many things from before that we loved coming back. You fold it, so let's just say this. Can you just reduce this? I know we're not officially doing fractions yet, but what is this reduced?
0.075.
No.
3 over.
Oh.
3/40, right? So it's one sheet of paper is 3/40 of a millimeter thick. Okay. So if you fold it once, how thick is it now? How thick would that folding be? It's the same thing as putting one piece of paper on another, correct? 6/40. Holy shit. If one is 3/40 and you fold it on top of itself, now it's 6/40 thick. Do it again and now it's,
9.
no, come on, we can do better. 12, right? Right? Once you fold it, it's 6. So now when you fold it again, it's 6 on top of 6. 12/40ths, yes? Every time you do it, you're doubling. You're not just adding 3. Every time you fold it, you're doubling it. Does that make sense?
By 2?
You're doubling it. Yes. Okay.
We're multiplying it by 2.
Yes, doubling. Yes. I like it. Does that make sense? If you fold something once, it's now twice as thick as it was.
Yeah.
So anything, whatever it was to begin with, it's twice as thick. So every time you fold it, it's twice as thick as it just was. So one fold would be 6/40ths. Or even better would be 3/20ths, but let's not go there. 6/40ths. Another fold, oh yeah, I'm writing really well today. Double this again. And then you want to do that 30 times. Do you actually want to do that 30 times? Or do you want to try to think about, is there a shortcut? Is there maybe an exponential way to do this? This is 3/40ths. One fold was 3/40ths times 2, yes?
Yeah, could you do 3 to the whatever power it was?
Not 3. What would 2 folds be? 3/40ths times 2
Oh.
times 2, right? Wouldn't that be 3/40ths times 2 squared?
Yeah.
Yes? And then you want to fold it 30 times. Okay, so I'm going to let you guys put that together. 2 folds, 2 twos. 1 fold, 1 2. You got to do 30. That's all I'm going to say. So you should look that up sometime. Well, we'll see how big it's big. It's going to get bigger than you think. Let me just say that. Anything else from homework about being really bored and folding paper or anything?
I was gonna ask for, actually for EF, when I was just working on it, what do you do to the 3 to the 3rd power? Because I know the 27,
Okay, so what did we do for the 9 to the 5th? Didn't we make that 3 squared, and that to the 5th is still there, yes?
yes,
And then what did we do with these?
you multiply.
Okay,
Oh, so
that's a general property. It's true no matter what the numbers are. If I have something to a power raised to another power, I multiply those powers.
So with 27 squared, I just put the 2 outside the 3 to the
Yeah, you're rewriting 27 as 3 to something, and that is being squared. I love it. So the 2 is still on the outside. You're just rewriting what the 27 is. And that's a huge thing in mathematics, is understanding what just comes for the ride and what you are working with at that moment. That is a huge place people make mistakes.
So we get the same bases, but the exponents, we can add them because it
Because they're the
multiplies.
same base. It's crazy. Can you always do that?
No.
No, damn it. If the 27, if they would have made that a 29, we would have been screwed. Right?
Yes.
Is there a power that I could raise 3 to and get 29? Is there a power that I could raise 3 to and get 29? Yes, there is. Just not a whole number, right? Oh, whatever, Jeff.
Do you have a stapler I can use?
Yes.
Because I just finished chapter
Okay.
4, and then also, how come I got 8E wrong in 3.3 set B?
Again, that it depends on what you did.
I'll
Yeah.
talk after class.
Yes.
Okay.
All right, guys. Anything else from homework stuff? You guys gotten into? Some of you guys have gotten into chapter 4, hopefully, because we're through 5.1, right? So here, let me tell you something. Okay, man, you guys look like. I really hope that I'm not making you all so depressed. I really hope I'm not. Are you guys doing okay? I don't know. You guys look like you're not doing okay. I'm sorry.
We're just stuck on chapter.
I'm a math teacher. I'm used to it being partially, at least partially me, is the reason. Yes.
I'm just barely learned chapter 4. Yes, of course I know it's mental completion. It's just how you're doing the work. And we're skipping to one chapter to another chapter, which we have to learn a whole new chapter, is a bit fast for me. I mean, in my case.
Anytime you want to, while I'm talking about anything, you can ask questions. Anytime. When I'm talking about anything. And part of the job of the teacher is to understand when you have enough time to address questions and when you have to say, no, you have to see me later for that. We have to keep going. So if I'm covering something that's not making sense, ask questions right then. Right then. And if there's not a lot of questions happening, I'm going to keep going. That's just natural. So one thing I like to say a lot is, if I'm going too fast, slow me down. If I'm going too slow, deal with it. Right? Does that make sense? So there's no way in hell I wish, oh my God, if I could read your minds, holy shit, my job would be great. My job would be easy. I can't. So I got to gauge it based on the questions I get. Right? Does that make sense?
Makes sense.
Okay, and I desperately hope that I don't make anyone feel like you can't ask questions. I'm trying to be very specific when there's questions I want to address later or something. Yes?
3.2 set A, number 18.
32A18.
It's a 3.3.
3.3A.
Oh, is that the, yeah, it messes me up too. 33A18.
Yes.
Okay. Oh, verify the transitive property of less than using the one-to-one correspondence definition. Dude, is that the one?
Yeah.
Okay, there's a lot to look up in that one, right? So what is transitive property? It's come up maybe twice, but that's you can look it up or you can ask me. So anybody remember what the transitive property was? Where'd it go? In fact, okay. So let me show you where they have page 116. There's the transitive property less than. I call it the duh property, I think. Did I call it the duh property? Does that sound familiar? Like if Alfred is younger than Bill and Bill is younger than Charlie, isn't it kind of like, well, yeah, Alfred's younger than Charlie. Holy shit, right? Alfred's younger than Bill. Bill's younger than Charlie. Ain't no way Alfred and Charlie are equal or Alfred's older. No way, no. This is officially called the transitive property, but I like to call it the duh property, right? Okay, I like that, maybe. So this one just says, now you gotta look up what, and one-to-one correspondence is from a while back. So I kind of like this problem because they bring us something from a while back. I don't think they referenced it in here again, did they? One-to-one course, I don't think so. Yeah, so that was from an earlier section. So look up one-to-one correspondence, or did you? Did you look up one-to-one correspondence? Okay. Look that up and see if you can see how it works into this. Anything else?
Let's see. Can we work on some of the 5.1 problems?
Sure, yeah. What you got?
So I just finished chapter 4 and I was wondering how far do you want us to make the factoring tree for number 2 for 5.1?
Oh, what do you mean how far?
By like, does it have a limit or can it be
Yeah,
limitless?
so let me make sure something about this book, because they just say a factor tree. There's a factor tree. They don't say prime factor tree. They just say factor tree, but it's a prime factor tree. So there's no, all right, there's no question about how far. You go as far as you can. The only question is, where do you start and why does not matter? So what's the first thing that comes to mind to anybody? How to break 36 up? What's the first thing that comes to your mind?
Find the, what goes into
No.
it.
Break 36 up.
2
What's the
times 12.
first, say again?
2 times 12.
6.
Try again.
6 times 6.
Okay, 6 times 6. Did somebody else have a different way?
12 and 4.
12 and, what is up with
3.
12s? Not 2, not 4, 3. There it is.
3.
All right. Well, it was really messy. Anybody else have a different way to start off? No, I like how it was.
Doesn't matter the way we start.
12 and 4.
Sorry.
If you're gonna be wrong, just be emphatically wrong. I like that.
Doesn't matter how we start off.
4 and 9.
Here we go. Okay, don't worry, I'm gonna get there. 4 times 9, right? I don't know why it doesn't matter. Wow.
2 and 18.
2 and 18, there it is.
And obviously 36 and 1.
Yeah, 36 and 1 is kind of the silly way to do it, but. Now, this is why I call it the DNA of the number, because no matter how you start to cut this apart, it's gonna end up in the same place. So DNA is supposed to be the parts that create a certain specific something. So when I break this down, so 2 is kind of done, right? How do I know 2 is done?
Can't break it down.
You can't break it down.
Because 2 is prime. Can't break it down. 18,
6 times.
Sure.
6 times 3.
I like it. 3 is done.
3.
2 times 3. So that would be 2 squared and 3 squared.
2 squared.
Right? 2 squared, 3
and 3
squared.
squared.
Right? I was thinking it's like a little weird tree, and these are little ornaments. And 4 times 9, wouldn't this be more directly 2 squared times 3 squared? Look at that. It's anything you do is going to be 2 squared. Anything you do is going to be 2 squared times 3 squared, right? If I take something and I break it down, no matter how I start, it's going to end up with all the same parts. It's not suddenly going to have a new part that wasn't. Somebody else broke it down like, I found this. What the hell is that? No, we're going to have the same parts. We just might start breaking it down in a different way, correct? Anybody ever took a tent down? We're putting them up. Don't start when it's getting dark. Start when it's still light. That's a good idea. But you can take it down in a few different ways. Worst ways to jump on it. It's not a good idea.
So it has to be a prime number, because I thought a prime number would be an odd number. So what are prime numbers exactly?
Careful, are prime numbers odd numbers?
No.
Nope. 2 is a prime number. Now, is every number beside every prime number except 2 odd? What do you guys think?
Yeah.
Yes, because if it's even, I can divide it by 2, so it's not prime. So in a sense, I'm with you. Every prime number is odd except 2. You guys with me? I like it. So what's your point?
So basically my point that anything, and you start off with any number, you'll still get the same thing.
Now be careful. Is every odd number a prime number?
No.
No. Good. I want to make sure that's not what you're thinking. Okay.
And also.
So a factor tree is not done until you got everything as far as it can go. So it ends at a prime number. So the more prime numbers we know, the more we're certain about where to stop.
Because I certainly reached it at 54. I only have 1, 2, and 3 3s.
Okay, cool. So that'd be 2 times 3 to the 3rd power. That's the one way you can write it. Okay. So let me do this. Anything else? Any other questions? Even from chapter 5? All right. So let me tell you this. Okay. See if this affects your depression at all. I'm not going to do 5-2 before this next test. I've got the practice test. I'm going to give it to you right now. We're going to start to look it over.
Yay.
Next time I'm going to have the answer key for that. So the test is going to be chapter 3, chapter 4, and section 5-1.
Yay!
I think that's enough information. Yes? I'm not going to try to cram 5-2 into your brains. Okay. So let me give you this.
Oh, I know, right? Same. Already stuck on the first one.
So notice this is front and back. And let me just say this real quick. Make a note for yourself right now. 16, 17, 18 would all be from 5-2. So 16, 17, and 18 will not be on this next test.
Okay,
Right?
so 16.
16, 17, 18. Now, I'm almost certain you guys could probably, most of you guys could probably do this anyway. Right? GCF, LCM. 18 might be freaky. Exactly. LCM and LCD are the same thing. I like it. So, what I thought we could do is, you've got a lot of homework to do, so you can do that at home. It's amazing how that works in. So what we can do in class is do this practice test. And like I said, on Tuesday, I'll have the answer key for this. So you can start working, you can work with other people if you want to, or by yourself. Call me over if you have some trouble.
Question.
Yes?
For the first problem, what's that squiggly line? It's just the thing they use for like adding. Or
It's an operation.
It just random.
Yeah, we picked this to mean plus, and then we went, what about times? Okay. So those are just dumb lines, right? We put a line and a line, and we went, what's that line and line mean? Let's call it addition. So that is my operation that works on A, B, and C, or whatever add up.
Oh,
Does that make sense? It's like, is it plus, is it times, is it minus? No, it's some other operation, and this is how it works.
how do I incorporate the 5 into it? This is what
Oh.
but I don't think that's correct. Because,
So 5B would mean like doing B, squiggly B 5 times.
oh,
Yeah.
okay.
Thank you.
I just need 5 and 5.
Yeah, I could have made that better. What's that? So
So
if
I
you
haven't
do,
tried.
what's C squiggly C?
C.
So if you do it 5 times, what do you get?
C?
Each time you do it, you get C, so yeah. Okay. That's why that one I could just say 5 of these, because every time I do it, I get the same answer. So what's a billion C? C.
What are those squig, I was gonna ask, what's those squiggly line mean?
All right.
This
So it's
one?
another operation, and that's how the operation works. It's like plus, it's like times.
Oh,
Yeah.
so we know that the parentheses always goes first, and it's B, 5, and C. But
So
then-
what's 5 C's? So if you do C squiggly C, what do you get?
So B,
No, C squiggly C.
C, squiggly C,
Yeah. C squiggly C is,
C,
so if you do it 5 times, what do you get?
C.
C.
But now I have to do squiggly A, do I?
Are you done on the inside of the parentheses?
Because we only did 5 squiggly C.
So rewrite the whole thing. What do you know now? This is B squiggly, what did we figure out here?
It's C.
Good, B squiggly C, in parentheses. Squiggly A. What do you have to do?
Parentheses,
Yeah.
B squiggly. So do I have to look from sideways